In this video, we'll be doing a very quick overview of Python syntax. It'll be very non-comprehensive, but hopefully it will give you a good place to start for learning the foundations of Python that you'll need for the rest of the course. If you're really not familiar with Python at all, I'd like you to take a look at this Python tutorial. This Python tutorial is in the official Python documentation and is written by some of the best Python programmers around. So from this tutorial, you should make sure that you are familiar with the concepts in chapters 1 through chapter 8. You don't have to look at section 2 here, because Houdini really handles all of this stuff for you. This might seem like a lot of stuff to go over, but most of these sections are pretty short. Okay, so if we go back to Houdini, we'll be using the Houdini Python shell for most of our testing and demonstration. So the first thing I want to talk about is variables. A variable in Python is basically the same thing as a variable in algebra. It's simply a container that can contain anything you really want it to contain. It could contain an integer, it could contain text characters, it could contain a float, really whatever. Now technically, variables are actually memory addresses, but you won't actually have to deal with that too much for the purposes of this course. Python actually handles most of that for you, which is a nice thing about Python for beginners. So how do you actually create a variable? In Python, if you want to create a variable, you just type variable name, say spam, and then type equals to set it equal to something, and then whatever you want to set it equal to. Let's say a number like 42. So now I have a variable called spam, and that variable is equal to a number 42. Now if I want to see what that variable is set to, I can simply type the variable name, like so, spam, and then hit enter. And then Python realizes that I'm trying to access this variable and just prints out the contents of the variable. So in Python, if you want to actually print something, so you can say something like print 42, and it prints 42. You can also say print spam, and it'll evaluate the contents of the variable spam and print it out for you. Now, there are a bunch of other different types of variables. The most common ones you'll probably be using are integers, floats, and strings. So an integer is what we have here, 42. It's a number without a decimal. If you want to make a float, in Python all you have to do is say something like spam equals 42, and then just put a dot at the end. And that tells Python that it's a float. Now if I say print spam, notice that it adds the 0.0 at the end because it knows that it's a float. Of course, if you want to, you can always give it a number that actually is a float, and it'll understand that as well. To make a string, you just set a variable equal to something that's in quotes. So if I wanted to make spam equal to a string, I could say spam equals and then something like blorg. And now if I print spam, there's blorg. So now that we have some variables to play around with, let's actually use them for something. So one of the simplest things we can use variables for in Python is using them to control conditionals. So what we can do is we can use an if statement to control what our script is actually going to do. So if statements in Python follow this syntax. You type if, and then a space, and then some expression that evaluates to true or false. In this case, I can just say true, and it'll do whatever I tell it later. And then you put a colon at the end. And the colon tells Python that the conditional expression is finished. And if you hit enter, notice that instead of these little symbols here, it's giving me an ellipsis. And that's to say that that's basically the Houdini Python shell saying, hey, I understand that you're trying to create something that's multi-line. So in Python, when you're creating a multi-line statement like this, the block of code that's contained inside the multi-line statement is always tab indented. And if you'll notice, it actually created spaces for me, which if you read that Python tutorial, you'll know why it does that. Alright, and then I'm going to type print blurg, which is something we've always been doing. And if I hit enter, notice that it gives me another ellipsis. This is because it still thinks that I'm doing a multi-line. So if I want to tell it that I'm done, I just hit enter again, and then it prints blurg. So what exactly was it doing here? Basically, when it hits this line, it says if true. It's checking this value to see if it's equal to true, which it is, because I'm just saying if true in this case. If that's the case, then it's going to do whatever is contained inside of this if statement. So basically everything after this that's indented once. So if I wanted to, I could do if false, hit enter, hit tab, and just type print blurg again, and hit enter twice. Notice it doesn't print blurg. And this is because the conditional evaluates to false. So now's a good time to talk about booleans. Booleans are another type of variable that we'd be using all the time. If I wanted to say something like egg equal false, this means that egg is a boolean. If I say print egg, notice that it's false. So the way that a boolean works is it's either on or off, true or false. It's just 0 or 1. So if you think about it, it kind of makes sense that conditional statements are going to be using booleans, because basically you're saying, I want to give you an expression, and it's going to either evaluate to true or false, and then if it evaluates to true, do something. If not, either don't do anything, or I can give you something else to do, and I'll show you how to do that later. So let's look at a more practical example of how to use conditional statements, and hopefully it'll become a little bit more clear. So suppose I wanted to do something, but only if spam is set to blurg. So if we print spam right now, we'll notice that it is in fact set to blurg. So I could type if spam. Now, you might be tempted to use a single equals here, but in fact we need a double equals, and I'll explain after this why. So if spam double equals, and then since it's a string, I need to use an open quotes, blurg, close quotes, and then don't forget your colon on the end. Hit enter, we see our funky ellipsis again. Remember to hit tab. And then let's just print hi. Hit enter twice, and notice that it prints hi. So the reason why we have to use a double equals here is because if you'll notice up here we're using a single equals. And so in Python, you can actually do conditional expressions on the terminal line the way that you can equals statements. So to Python, it needs a way of differentiating this, spam equals blurg, from this, is spam equal to blurg. And the way that it does that is simply by adding an extra equals sign. So when we're doing if statements, you have to use the double equals if you're testing for equality. Alright, so right now if we print spam, we can see that it's still equal to blurg. That's all well and good. So let's take a look at what happens if the if statement's expression evaluates to false. So if I set spam to something other than blurg, say fawn, and then I do spam double equals blurg, which is the same expression that I was testing here, you notice that it returns false now. So now, if I say if spam equals blurg, now this expression evaluates to false. So now we're basically doing the same thing as we did here. And let's just test that to make sure that it happens. So say print hi, double enter, and indeed nothing gets printed. So why would we ever use this? Well, we use if statements to compare two values, and they're especially useful if we don't necessarily know what the value of this variable is going to be. Maybe it's coming in from the user, or maybe it's coming from some source that we don't know about. Or maybe it's the result of a calculation that comes from something that's outside of our program. Okay, so what if we want to print hi if spam is equal to blorg, but do something else if spam is not equal to blorg? We can do that using an else statement. So basically what we'll do is we'll just retype this if spam double equals, not triple, in single quotes, blorg, colon, hit tab, print hi. And notice that we still have the ellipsis here because we did not do the double enter. So what we can do is say else. And now when Python sees this else statement, it's going to look up and find the previous if statement. And if it finds one, and if there are no unindented lines in between them, then it'll attach itself to that else statement, to that if statement rather. So basically what you're saying is, if spam equals blorg, do this. Otherwise, we'll do something else. So if I hit enter, notice I still have my ellipsis. And then hit tab, and we'll say print by. Hit enter twice, and indeed, it prints by. Alright, let's make it a little bit more complicated. Yay, complication! So, what if we want to say, well, if spam is equal to blorg, I want to do one thing. If spam is equal to something else, I want to do something else. And then, if it's neither of those things, I want to do even a third thing. And we can do that by making it a little bit more complicated. So let's just go ahead and type out our previous statements. Spam double equals blorg colon print hi. And then Python has this special syntax, ELIF. So you would say elif, which is essentially saying else if. So then I could test to see if spam is equal to fon. So if elif spam double equals fon. In this case, lowercase. In this case, print by as before. And then if it's neither of those things, I can just put another else at the bottom, and it'll compare itself to all of these. I can say print something misspelled. Hit enter twice, and we get by. Because spam is indeed equal to fon. Okay, so let's go over some other ways of using conditionals. There's some ways of using conditionals that are more specific to numbers, so we can test for equality, or rather for inequality. So the way that we do that is with greater than or less than symbols, and I'll show you how to do that in a moment. First, let's just let's just set our variable spam to some number. Let's say 42 again. Alright, so say we only wanted to do something if spam was greater than 42. Or greater than 50. So if we say if spam, we just use the greater than symbol. That's the one that points to the right. 50 with our colon. Print hi. Notice that it doesn't happen. However, if we want to test for less than, so do spam less than 50, print hi, it does print, because spam is 42 and 42 is less than 50. Now the funny thing about this is that if our variable is actually equal to the number that we're testing inequality for, this might not work the way that you would think. So if we do if spam is less than 42, print hi, you'll notice that it doesn't print. And the reason for that is that spam is actually not less than 42, it's actually equal to 42. So what if we want to say, do something if spam is less than 42, but we also want to do it if it's equal to 42. In that case, we use less than equals. So we say if spam is less than equals 42, just right next to each other like that. Print high. And in this case, it's actually true, and we get high. The next thing we need to do is look at how to combine conditional statements so that they can form more complex conditionals. The way that we do this is with the AND and OR statements. Just as before, where we were looking at the way that Booleans work outside of if statements, we can look at the way that AND and OR statements work by themselves outside of if statements. So let's look at OR first. OR basically means if any statement surrounding it is true, then OR returns true. So if I do true or false, it gives true, because there's a true and there's a false. So one of these is true, so it returns true. If I do true or true, it also returns true, because at least one of these statements is true. If I do false or false, it returns false because there's no true statement surrounding it. So it's basically a way of saying I have two different conditional statements, and if either one of them is true, I want to return true. So if we look at the way that this works with an if statement, we can say maybe something like spam equals 42 if spam is less than 40 or spam is greater than 40, print high. So if we step through what this is doing, the first thing it does is it looks at is spam less than 40. That's actually false. The second thing it does is look at is spam actually greater than 40. This is true because spam is 42. So this is the same thing as typing if false or true, print high. So you might be wondering why it didn't just go left to right. The reason for that is that the order of operations that Python does is these kinds of conditional statements that combine other statements are done last. So it's always going to evaluate all of these types of conditionals first, and then this type of conditional last. Alright, so let's go and look at AND statements now. AND statements are very similar to OR statements, except that for an AND statement, everything surrounding it has to be true in order for it to return true. So if we do the three test cases that we did before, except with AND this time, true and false, this returns false, because only one of the statements surrounding the AND is true. If we do true and true, it returns true, because both the statements surrounding the AND are true. And if we do false and false, it returns false because none of the statements surrounding the AND are true. So AND is basically a way of making sure that both conditionals evaluate to true before you actually do something. So if we look at the way that this works in an if statement, we can say if spam is less than, or let's say greater than 40, and spam is less than 50, print high. And it does print high. So if we look at the way that this is working, it does this first statement, spam greater than 40, spam is 42, so this is true. Then it does this statement, spam less than 50, spam is less than 50 because it's 42, 42 is less than 50, so that's true. So this is the same thing as doing if true and true, print high. Now if one of these statements evaluates to false, let's just check that and make sure that we understand what's happening. So if we say if spam is greater than 40, we would expect this statement to evaluate to true because spam is 42. and then we do and we do spam is less than 41. We'd expect this statement to evaluate to false because spam is 42 and 42 is not less than 41. Print hi. In this case, it doesn't print hi because this is false. So this is the same thing as saying if true and false. Print hi. Now that we know how to control our program using if statements, let's take a look at how to make that program do something really efficiently. One of the great advantages to scripting over just doing everything by hand is that you can make it do similar tasks over and over and over and over again an unlimited number of times without you having to sit there and monitor it. And we can do that using something called a loop. Before we can look at the simplest kind of loop in Python, which is called the for loop, we need to take a look at a new variable type called a list. So let's look at how to define a list. If I say something like spam equals open bracket 0, 1, 2, close bracket, and hit enter, and then I just print spam, you'll notice that it gives me this same syntax back. This is called a list. A list in Python is a simple sequence of items. These items can be anything. They can be variables, they can be strings, anything. Python also doesn't limit what types of items go into lists. So I could say something like spam equals 0 blorg 2. And you'll notice in this case that blorg is a string while everything else is a number, in this case an integer. If I hit enter, Python is totally okay with this. I can say print spam, and it's completely happy. Now, Python has a special function built into it called range, which generates this sort of list where it's just numbers counting up from something to something else. So if we take a look at range, if we do range, hit the open parentheses, you can see that it brings up a nice little help panel right here. So the way this works is you give it a first number and then a second number, say 15. And it'll count up from the first number to the second number. Now, notice that it didn't actually count up to and including 15, it just stopped at 14. And that's because it's using that less than operator that we talked about earlier. The reason for that is that you can actually omit this first number here and just say range 15. And it goes from 0 to 14 again. And in this case, what you want is to actually have 15 elements, which you can see. There are 15 elements. If we wanted to check on that to make sure there are actually 15 elements, there's another special function that Python gives us that works on lists. That's called len, L-E-N. If we do len range 15, we can see that it's 15 elements. And len just counts up the number of elements in the list. Len will work no matter what we have in the list, so if we gave it this string up here, it wouldn't matter, it would just still count this as 3. So how does this relate to loop? Well, in Python, the for loop only ever loops over lists. And this might seem like an unnecessary complication, but actually most of what you use for loops for is looping over lists anyways, so it's actually something that makes things a little bit easier. So what we can do is we can say for, say, I in range 15, colon. And now if we hit enter, you can see that it gives us the ellipsis again. And this is because we're starting a loop, and then we need to tell Python what we actually want to do inside the loop. So if we hit tab again, because remember, anytime we create a multi-line statement in Python, we have to hit tab to tell it what's actually inside our multi-line. And I'll just say print I. And don't worry if you don't quite grasp the specifics of what's going on here. I'll go back over this in more detail in a moment. So if we hit enter, again, notice it's giving us this ellipsis again, which means that we have to enter again. Alright, so it's counting up from 0 to 14. So what exactly was it doing there? So the first thing it does is it sees this 4 and it's like, aha, I need to loop. So the second thing that you do is you give it a variable name. This can be anything. Basically, it's just going to contain whatever the current element is in the list that you're looping over. Then you use this in keyword, which is part of the for syntax, and you're giving it range 15, which is just returning this list. So basically what you're going to do is it's going to run everything in this block of code once for every element of this list. So we gave it range 15, so the first thing it's going to do is it's going to run all the code underneath on 0, where I is equal to 0. Then it's going to run it where I is equal to 1, where I is equal to 2, and so on, all the way up to 14. So the code that we're actually giving it is print I. So for the first element in the list, I is equal to 0. So when it prints I, it just prints 0. Then it goes back up again, and it says, okay, well I is equal to 1 now, and it says print I, so it prints 1. Then it goes back up again, well I is equal to 2 now, so print I, so it prints 2, and so on all the way down to 14. So just to make this a little bit clearer, let's define our own list and then loop over that and see how that works. So if I say spam equals open bracket for a list, open quotes for a string, blorg, comma 42, comma fon, comma last element, close quotes, and then close brackets. So if I print spam right now, this is what we have in the variable spam. So spam is a list and we want to loop over that list. So if we just do the exact same thing that we did up here for our for statement, and we say for I in spam, so whoa, that's a bit weird. We're actually doing for I in our variable name, right? Remember that this range function is actually just returning a list, so we can very easily just give it our own list, and then loop over that instead. And in fact, that's what the for statement is really for. Alright, so then we can just hit enter, hit tab to indent. Remember, it has to be indented. And then if we just print I again, and hit enter twice, you can see that each time it printed an element from our list. And just to go over it again, so it sees this for statement, it's going to set I for each step to whatever the current element is. So for the first step, it sees I, it says, okay, so I equals blorg as a string. It hits this print statement, it says print I is blorg, so it prints blorg. Then it goes to the second step and it says, well now it's 42, so set I to 42, it sets I to 42, print I is 42, so it prints 42. And so on and so on and so on, until we hit last element. It prints that and it exits the loop. So what if instead of looping over a list, we want to just loop endlessly until some condition is met? Luckily, Python provides us with another type of loop that allows us to do exactly that. This is called the while loop. The syntax of the while loop is very simple. We just say while and then some conditional statement. Now I'm not actually going to run this while loop because this is what will be called an endless loop, which means it'll just be looping and looping and looping and looping on to infinity until you force it to quit. Instead, I'll give it some conditional. So what I can do is say something like spam equals 50. And now I can say while spam is greater than 25, for instance. And notice that again, I'm tab indenting because we're creating a multi-line statement. And then I can do something like print blorg. Now, if I hit enter again right now, what it's going to do is it's just going to loop endlessly. Why is that? Well, that's because we're not doing anything to the variable spam. So all we're doing is we're comparing spam against 25. Spam is equal to 50, and every time it loops, spam is still going to be equal to 50. So basically what it's going to do is it's going to loop while spam is greater than 25, it prints blorg, comes back up, does this comparison again, while spam is still 50, so it's still greater than 25, so it'll print blorg, and it'll keep going and going and going and going and going, expecting spam to eventually not be greater than 25, even though it's not doing anything to it. So what we need to do is actually give it some reason to stop. And we can do that very simply by hitting tab again. Notice that both these lines are indented, so that means that they're both part of this while block. And then we just say spam equals spam minus 1. And basically what this is going to do is it's going to take the variable spam, it's going to set it equal to this statement. In this case, it's spam minus 1. So if I hit enter and then hit enter again, it prints out blorg a whole bunch of times and then stops. So again, if we step through what this is going to do, it sees this while statement which says, okay, so I need to loop for a whole bunch of times. And then it sees this conditional, and this is its exit condition. So it's going to say spam is greater than 25. Well, spam equals 50, so spam is indeed greater than 25. So then this evaluates to true, so then it does everything inside, which is print blorg, and then it decrements spam. So spam now equals 49, so then it goes up here again and it says, well, spam is greater than 25 still, so print blorg again, and so on, until spam slowly gets decremented all the way down to 25, and then this evaluates to false, and the loop quits. The last Python concept that we need to look at before we start getting into Houdini-specific Python is what's called a function. We've actually used functions before without actually knowing what they were necessarily. You can think of a function as a way to create a tool that you can then use inside your script. You can also think of it as a way to take a block of code and then turn it into something that you can repeat over and over again. So let's take a look at how to define a function, and hopefully this will become a little bit more clear. The syntax for creating functions in Python is using the keyword def, D-E-F. And notice that my Python shell highlights that. I then give it the name of the function, say blorg, open parenthesis, close parenthesis, and then a colon. And again, we'll be going over this syntax in more detail in a moment. Hit enter. Once again, we get our ellipsis telling us that we're making something that's multi-line, so we have to hit the tab key. And then let's just give it some statement, and then we'll take a look at what it does. So say print, open quotes, blorg, close quotes. Hit enter. We're still doing our multi-line, so we have to hit enter again to get out of the multi-line statement. Okay. And then let's just go ahead and use this, and then we can go over the syntax. So the way that you use a function is you type the name of the function, in this case blorg, and then open parenthesis, and then in this case we're just going to do close parenthesis, and hit enter. And then it prints blorg. So what is this actually doing? The first thing that we did was we used a def statement, which tells Python that we want to create a function. Then we give it a function name. In this case, I'm just giving it blorg. You can give it any name that you want to. It's generally best to make sure that your function names relate somewhat to what the function's actually doing. The open close parentheses are there for defining arguments, which we'll do next. Then we have a colon, which tells Python that we're actually done defining the name and all the arguments for the function. Then we tell it what the function's actually doing, and we do that by providing it with other Python statements. In this case, it's just going to print blorg no matter what. Then when we use the function, and what that's called, the way that you refer to using function is you say that you're calling the function. So in this case, we're calling the function called blorg. Is you type the name of the function, and then you type open close parenthesis, and in here you can provide what's called arguments, and we'll look at that later. And then what Python will do is it will run the code inside the function. In this case, it's only print blorg. So then it prints blorg. Now the great thing about this is that we can call this function any number of times that we want to, and it'll always do the same thing. So if we say blorg again, open close parentheses, it prints blorg. We can do it again. prints blorg. So now we've created a tool for printing blorg. Now, what if we wanted to create a tool that just prints whatever we tell it to print? This is where we start using arguments. So we'll need to redefine our function slightly. Let's just type def and then blorg again. And in this case, we'll just be overriding the function blorg, so it'll do something else instead. And then we can give it an argument name. Let's say arg. Arg short for argument. Close parenthesis, and then a colon. And what this is doing is it's telling Python that I'm defining a function named blorg that has one argument. I'm just calling that argument arg. This is a variable name that I can use inside the body of the function. If I enter, hit tab again, now I can use this variable arg for whatever I want to inside this function. In this case, I'm just going to print it, so let's say print arg. And if I hit enter twice, let's see what it does when we call it. So if I type blorg, and I hit open parenthesis, notice that the Python shell gives me this wonderful little tooltip here telling me exactly what blorg is. It says that blorg is a function, and then inside the parentheses it says that you need to provide it with an argument. And that argument's called arg. So if I give it something, say, in quotes, this is an awesome argument, close quotes and close parenthesis, and then hit enter, it prints out this is an awesome argument. So basically what this is doing is I'm calling the function blorg because I have blorg and I have open parenthesis, and then I give it this argument. So when Python does this, it goes up here to this def, it says, okay, so here's blorg, I need an argument, that argument is set to what the person calling it set it to. And it's going to, it's just this one statement, print arg. So arg is set to whatever I set it to when I called it, and then when I say print arg, it just runs that code. So in this case, it just runs that code to print arg, and it runs, this is an awesome argument. So I can use blorg to print out whatever I want to. This is a very powerful way of working because you can define functions that do common tasks for you. For example, let's say that I'm writing a script where I'm always adding two numbers together, and I'm doing this a lot. Rather than constantly typing 2 plus 2 or 5 plus 5 or whatever, I can define a function that does that. So let's try that. So if I say def add numbers, open parenthesis. Now in this case I want to give it two arguments because I want to add two numbers together. In order to do this, I need to have two different arguments. And the way that I do that is by using a comma. So I could say arg1, comma, arg2, close parenthesis. And this is telling Python that the user is going to give me two arguments and I'm going to use them inside the function. I then do my colon to tell it that I'm done defining the function. I hit enter, and now I can start writing the body of my function. So in this case, I'm just going to say print arg1 plus arg2. If I hit enter twice, it's just going to print out those two arguments added together. And if I use this function, I can say add, open parenthesis, let's say 10 and 15, and it should give me 25. And it does. So now whenever I need to add two numbers, I can just give it those two numbers using this add numbers function, and that makes things a lot more concise. This is kind of a nonsense example since two numbers added together is a simple thing to do, but I think you can easily imagine that there could be much more complicated tasks that we want to perform where we only need to change one thing and then it does the whole thing all over and over again. And actually we'll be looking at an example like that next. Okay, so what if I want to use my function to actually set a variable? Well, if I say spam equals add numbers 10, 15 right now. So it prints out this 25, and you might think that spam right now is actually set to 25. But if we say print spam, you'll see that it's actually set to none. And this is because add numbers isn't actually returning a value to set into spam. What does returning a value mean? Basically, returning a value means that you're telling Python to send a number out when someone uses this equal. So the way we do this is if we redefine add numbers. I could just retype def add numbers, and when you're first starting out, it's probably a good idea to do that as much as possible. But just to save on time, I can use the up arrow also. And that'll get me back to add numbers. If I hit enter, instead of saying print arg1 plus arg2, I can just say return arg1 plus arg2 and hit enter twice. And now if I go back to my spam equals add numbers, notice that nothing immediately is printed out, and that's because I removed the print statement. So now it's only return, so it doesn't print anything. Now if I say print spam, you can see that spam is set to 25 now. So let's just take a look at a slightly more complicated example that pulls from some of the concepts that we talked about earlier in this video. What we'll do is we'll make a function that adds together all the numbers in a list. The way that we can do this is by using a for loop and a function. So let's first define the function. We'll say def add numbers. We'll take an argument, say just arg, or actually let's even tell it what it needs to be. So let's say list to add, close parenthesis, and then open colon. And now if I hit enter, okay, so now ostensibly I have this list to add variable, and that'll give me a list, assuming that the user gives me a list. So assuming that that's a list, how do we go through and add all the numbers in the list? Well, the first thing that we want to do is we want to define a variable to contain the running summation. So if we say sum equals 0, this means that every time the function is called, we'll have this other variable called sum inside of it. And sum will be first 0. The next thing I want to do is create a for loop that loops over all the elements in the list that we've been provided. So let's say for I in list to add, the colon, hit enter. So if I tab once, that means that I'm part of this function but not part of this for loop. So I have to hit tab again, and that puts me inside of this for loop. Python would actually get confused if I were still back here, because it would think that I'd created a for loop with nothing inside of it, and it will actually complain. So now that I'm inside the for loop, I just want to say sum equals sum plus I. And you might be thinking that this is kind of cumbersome, because I keep having to say sum equals that variable plus something else, and you're not the only one who thinks that. So there's actually a shorthand in Python to do this. All I have to do is say plus equals I. And basically it means I'm going to take this variable and set it to itself plus whatever I gave here. So this is the same thing as saying sum equals sum plus I. Now I hit enter again, and I tab out again. Now we have actually added up all the numbers at this point, but there's no way for whoever's calling the function to know that that actually happened. So let's just go ahead and return sum at the end. I'll hit enter twice. And now we just say print. Well, actually, first we need to create a list to add up. So let's say spam equals open brackets, and we'll just give it 3 numbers to make sure it's working. Let's say 10, 20, and 35. So if this is working, we should have 10 plus 20 is 30, 30 plus 35 is 65. We can print spam to make sure that it actually set it to what we think it is, which it is. And now we just do print add numbers, and then we give it spam, which is our list. And if we hit enter, 65. Okay, so what is this actually doing? So Python hits this def statement, and it says, okay, I'm making a function. We give it a name, add numbers. The open parenthesis tells Python that we're going to give it some arguments, and then we give it list to add. This is telling Python that we want our users to give us at least one argument, and that is going to be dumped into a variable called list to add. Close parenthesis says that we're done defining arguments, and then the colon says that we're done defining the name of the function. Sum is the number that we're going to be slowly adding up as we loop over all the elements in the list. Then we hit this for loop, which means that we're going to loop. We're going to use I as the variable to store the current element in. We're looping over list to add, which is our argument that was set by the user when we call it. Every time we hit a new element in the list, we add that element to sum. The way this works is I is set to the current element in the list, and then I is then added to sum using this plus equals syntax. Once we get to this return statement, we're done with the loop entirely, because there was only this one statement that was tab indented twice. So at this point, sum is set to all of the elements of this list added together. So we just return that value. Then when we come down here to print add numbers, we're simply calling it because we typed the name of the function, we typed an open parenthesis, and then we gave it a list to loop over as an argument, close parenthesis. So just to be completely clear, let's just go through what it's actually doing with numbers. So when Python hits this add numbers, it calls it with this argument. So it goes back up here. It's setting this argument to a list. This list we defined here to be 10, 20, and 35. So that's what our list is. It sets this sum equals 0. And then as it loops, it says, for the first iteration of the loop, it says, we'll set I equal to 10, because that's our first value in the list. It says sum plus equals I. I is set to the first value on the list currently, so it's set to 10. So sum equals sum plus 10 is 10. Then it goes back to this for statement again, and it says set I equal to the second element of the list. The second element of the list is 20. Sum currently is 10, and so it's going to say 10 plus 20 is 30, so it says sum is now equal to 30. Then it hits the third element in the list, which is 35, so it sets I equals to 35. Then it says sum, which is currently 30, equals sum plus 35. Since sum is 30, that's 30 plus 35, which is 65, which gets set to sum. So now sum is set to 65. There are no more elements in the list, so this block is done. So then it goes down to the last statement of the function, which is return sum. Sum is 65, so it's just going to return 65. So when we say print add numbers spam, add numbers is going to run through that whole process I just detailed, and it's going to print the result of it, which is 65. This concludes our brief overview of a lot of basic Python syntax. We went over a lot of material very quickly in this video, so if anything's not clear, please ask questions, as this is basically the foundation of the course. If you're not clear on anything in this video, it's likely that it'll come back to bite you later.